Moving on to the third section, we're talking about domain now without graphing. So the things you have to know about domain is in a fraction, the denominator cannot equal 0. Under a radical, the radicand, the number underneath, cannot be negative. So here we're talking about a fraction, so we factor the bottom to see where it equals 0. Well, if it factors into x minus 3 and x minus 2, then the denominator equals 0 when x is 3 and 2. So the domain, we would say, is all real numbers except 3 and 2. Or you could do negative infinity to 2 union 2 to 3 union 3 to infinity. All of those are acceptable as long as you understand that x cannot equal 3 or 2 in this case. This one's a little bit trickier because you have to think about when the denominator would be negative. We need it to be positive. So you need x squared minus 4 to be greater than 0, which means you need x squared to be greater than 4. But then when you take the square root, you end up with something like x is greater than plus or minus 2, but that doesn't really make sense because what you're really doing is saying the absolute value of x squared has to be greater than 4. Now I'm going to do another lesson, or I might have already done it, on solving absolute value inequalities. And what you do when you do that is you have to say, sorry, it's not the absolute value of x squared. When you take the square root of x squared, you get the absolute value of x. So now, when you write an absolute value equation and it's greater than, it means it has to be on this way of negative 2 and this way of positive 2. So you're saying from negative infinity to negative 2, inclusive, because negative 2 squared is 4, and 4 minus 4 is 0, and that's allowed. You're allowed to take the square root of 0. Union, nothing in here, but then from 2 to infinity is also allowed. So again, I'm going to talk more about this, absolute value inequalities, in another video, but that's the main idea. Up here, we need the denominator to be positive and not equal to 0. So what I would suggest is understanding what this is a graph of. It's a parabola. You know the zeros are negative 4 and 3, and you know that it's holding water because the leading coefficient is positive. So if I'm looking at this, I don't care what the y-intercept is. All I care is that it's holding water and it crosses the x-axis at negative 4 and positive 3. So to understand when this graph is positive, you simply have to think about the graph of the parabola. When is it above the x-axis? That's when the function is positive. Well, from negative infinity to negative 4, it's above the x-axis, and from 3 to infinity, it's above the x-axis. But at the points 3 and negative 4, the denominator actually equals 0. So that's why we have to exclude negative 4 and 3. This is going to show up a lot in calculus, so try to make sure you understand this whole concept of when a parabola is positive and when it's negative. There's no restriction on domain for absolute value. Anything you want to put in for x, you can put in, you'll get a real number out. So no restrictions on the domain for f of x. I mean for absolute value. I'm going to do the next section now too because it's pretty quick. Just understanding this notation, composing f of g of negative 1 means put negative 1 in for g, which gives you negative 3, and then plug that into f, which gives you 9 plus 9 is 18 plus 1 is 19. This is just saying f of g of x, so instead of putting in a number for x, we're just going to put in x. So you take g of x, x minus 2, and you plug it in for x wherever it appears in f of x. So it looks like this. X minus 2 squared minus 3 times x minus 2 plus 1. When you square a bi, you get a trie. When you FOIL this out, this is what you end up with. Then you have to distribute the negative 3, so you get a plus 6. So when you combine all your like terms, your final answer is x squared minus 7x plus 11. This is just another notation of this. They mean the same exact thing. So we're going to take f of x and put it into g of x. That one's easy because you don't really have to do anything to it except subtract 2. And when you do that, you end up with x squared minus 3x minus 1.